There are many ways to solve systems of equations. Today we will be looking at how to solve systems by graphing and by using the substitution method. One way to solve a system of equations is by graphing both equations. The solution to the system will be when both of the equations are satisfied by one ordered pair. This is the intersection of the two lines. For this example, we're asked to solve the system of equations by graphing. The two equations are 4x plus 2y equals 8 and 6x minus 2y equals 12. To graph both of these lines, we can use an xy table shown at the bottom left. For the first equation, we can plug in x values to find their corresponding y values. So to begin, if we plug in -2 into this equation, we find that y equals 8. So we can plot these points on our graph to the right. After plotting the points, we can connect them, drawing the line for this equation. Next, we can continue to do the same thing for the second equation, plugging in x values to find their corresponding y. Once you've plotted these points, again, connect them, drawing a line through the ordered pairs. As you can see, both lines intersect at the point 2, 0. This is the solution to the system of equations. Another way to solve a system of equations is by using substitution. The substitution method may be an easier method to find a solution if the coordinates are difficult to read or if one of the equations can be easily solved for one of the variables. For example, if we're asked to solve the system 5x minus 3y equals -6 and x equals 2 minus y, we see that the x is already solved for in the second equation. So we can substitute that equation in for the x term in the first equation. After doing so, it would look like this. 5 times our 2 minus y that we're plugging in for x minus 3y equals -6. To finish, we would solve for y. Now, let's do an example using the substitution method. Solve the system 6x minus y equals -9 and y equals -7x minus 4. Since the second equation is solved for y, we can substitute that -7x minus 4 into the first equation for y. When doing so, we're left with 6x minus that -7x minus 4 equals -9. We can use the distributed property to distribute this -1 into the -7x and into the -4. Just a refresher, when we use the distributed property, we multiply that number in the front of the parenthesis by whatever's inside the parentheses. So if we have that -1, we distribute it to the -7, we're left with 7x. When we distribute a -1 to the -4, we have -1 times -4, which is a +4. And that's how we get this 7x plus 4. After combining like terms, we're left with 13x plus 4 equals -9. And solving for x, we find that x equals -1. We found that x equals -1. Now we can substitute that -1 in for x in one of the equations to solve for y. It doesn't matter which equation you choose as long as you solve for the y in that given equation. So let's choose the second equation to plug in x equals -1. So we have y equals -7 times -1 minus 4. When solving for y, we get y equals -3. We know that x equals -1 from before, and now y equals 3, giving us the ordered pair -1, 3. To check our solution, we can plug it in the ordered pair into both equations to make sure the statements are true. So if we plug in -1, 3 into the first equation, We plug in the -1 for the x and the 3 for the y. When simplifying, we find that -9 does in fact equal -9. Again, we have to do this for the second equation, so we plug in the -1, 3, for -1 for the x and 3 for the y. And we simplify to find that 3 does equal 3, therefore this ordered pair is a solution to this system of equations.